Hello everyone, this is Nicole Inoferio, and for this video, we are going to dive into the world of conservative forces. This video embarks on a journey to explore the properties and effects of conservative forces. That's our topic for today. First, what is conservative force? Conservative forces are defined as those that do not depend on the path taken by an object, meaning that the work done by the force on an object moving between two points is the same regardless of the path taken. In other words, the work done by conservative force on an object moving from one point to another is dependent of the path traveled. Let's have a situational example. Lifting a book from the floor to the table. We have two examples in lifting a book. When you lift a box straight up from the ground to the table, and the other one is far from where the table is located. Did you notice the distance between the two books? It is because conservative force doesn't depend on the path traveled. The book may be a little far from the table, but nonetheless, the height between the book and the table is still the same. It depends solely on the book's initial and final heights, irrespective of the path taken. Let us now have the example of conservative forces. The example of conservative forces are gravity, elastic forces, and electrostatic forces. Gravity refers to the force of attraction between any or two objects with a mass. It is a conservative force because the work done by gravity on an object moving from one point to another is dependent of the path taken. The work done by gravity on an object depends only on the initial and final heights, not the path it takes. Second one is elastic forces. The elastic forces is the force exerted by a spring when it is stretched or compressed. It is a conservative force because the work done by the spring on an object moving from one point to another is independent of the path taken. For example, if you stretch a spring and then let it go, the work done by the spring on the object is the same whether the object moves in a straight line or a curved path. Third one is electrostatic forces. Electrostatic forces refers to the force that governs interaction between charged objects at rest. Is a prime example of conservative force. For example, rubbing a balloon on your hair. When you rub a balloon against your hair, this leaves the balloon with a negative charge and your hair with a positive charge. The opposite charge then attract each other, causing your hair to stand on end. Let us now move on to the properties of conservative forces. First is path independence. The work done by a conservative force on an object moving between 2 points is independent of the path taken. This means the work done is the same regardless of the route the object follows. Potential energy. Potential energy is defined as the energy stored with a system due to its position or configuration. This type of energy is independent on the relative position of object within the system and is associated with the forces acting on this object. Energy conservation. When only conservative forces act on a system, the total mechanical energy, PE or potential energy, plus KE or kinetic energy remains constant. This means that energy can be transformed between potential and kinetic forms, but the total amount of energy stays the same. Zero net work in a closed loop. If an object moves along a closed loop, starting and ending at the same point, under the influence of a conservative force, the net work done by the force is zero. This is a direct consequence of path independence. In any closed path, the work done by a conservative force is equal to zero. Conservative forces are associated with potential energy. The existence of a potential energy function is a defining characteristic of conservative forces. These functions allow us to calculate the energy stored in a system due to the force's influence. So what are the effects of conservative force? Energy transformation. Conservative forces enable efficient energy transformation between potential and kinetic energy. Energy conservation. The most fundamental effect of conservative force is the conservation of mechanical energy. When an object is acted upon by only conservative forces, the total mechanical energy, Potential plus kinetic remains constant. Another effect of conservative forces is the existence of potential energy function. Conservative forces are associated with potential energy function, which describe the energy stored in a system due to the position of object within it. The potential energy function allows us to calculate the work done by conservative force and the change in energy a system as object moves within it. Let us also know what is non-conservative forces. Non-conservative forces are forces that do not conserve mechanical energy, with the work done being dependent on the path taken by an object. Examples of it are friction, air resistance, tension, or applied force. Non-conservative forces such as friction do depend on the path taken. The work done by friction on an object is directly proportional to the distance traveled. This means that the work done by friction will be greater if the object traverses a longer path. And that's all for today. Did you learn something about this video? I hope you did. Again, this is Dan and Nicole Inoferio. Thank you for watching.